Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Data Structures in Python, Part 3, Algebraic or Arithmetic Expressions, Infix, Prefix and Postfix Notations. Conversion from Infix to Postfix notation with algorithm and visualization using stack method for the Class 12 students of Computer Science. So, let's dive in and get started. Let's start with an interesting topic in data structures using stack. Before getting into that, first we should know what's an algebraic or arithmetic expressions. Algebraic expression is a valid combination of operators and operands. Operand is the quantity upon which a mathematical operation is performed. It can be a variable. For example, x, y, z, or a constant, for example, 5, 4, 6. Next is the operator, which is a symbol that represents a mathematical or logical operation between operands. Examples of operators. Common operators include plus, addition, minus, subtraction, asterisk, multiplication, slash, division, and raised to the power, exponentiation. Let's discuss about the notations for algebraic or arithmetic expressions. Algebraic expressions can be represented in three notations: infix, prefix, and postfix. In infix notation, arithmetic expressions are written with operators placed between operands, such as x plus y, 2 minus 3 asterisk y, etc. You can see the highlighted operators between operands here, representing operators placed between operands. Parentheses are used to specify the order of operations in complex expressions. The BODMAS, brackets, orders, division and multiplication, addition and subtraction, rule is applied to evaluate expressions in infix notation. Polish notation or prefix notation. This was introduced by Polish mathematician Jan Lukasiewicz in the 1920s. In prefix notation, operators are written before their operands. The order of operations and operands determines the result, eliminating the need for parentheses. For example, x plus y in prefix notation is written as plus xy. You can see the highlighted operator plus before the operands x and y, pre means before. Reverse Polish notation, postfix notation. In postfix notation, operators are written after their operands. It is the reverse of prefix notation. For example, x plus y in postfix notation is written as xy plus. You can see the highlighted operator plus after the operands x and y, post means after. Let's recall the three notations with examples. In infix notation, operators are placed in between the operands. For example, x asterisk y plus z. You can see the operators asterisk and plus are between the operands x, y, and z. Likewise, look at the second example. 3 asterisk, 4 plus 5, and the third example, x plus y, slash, z asterisk 5. In prefix or Polish notation, operators are placed before the corresponding operands. So, x asterisk y plus z is written as plus z asterisk xy. 3 asterisk 4 plus 5 is written as asterisk 3 plus 4 5 and x plus y slash z asterisk 5 is written as slash plus xy asterisk z 5. Now, let's see the postfix or reverse Polish notation. Operators are placed after the corresponding operands. So, x asterisk y plus z is written as xy asterisk z plus. 3 asterisk 4 plus 5 is written as 3 4 5 plus asterisk. X plus y slash z asterisk 5 is written as xy plus z 5 asterisk slash. You can gain a clearer understanding by learning how to convert these notations. So, simply follow the concept. Now let's learn about the conversion from infix to postfix notation. First, let's learn about the basic concepts of these conversions. Infix expressions. Infix expressions are the most common way humans write arithmetic expressions, where operators are placed between operands, for example, x plus y/z. Humans can evaluate infix expressions by following the order of precedence, Bodmer's rule, to determine which operations to perform first. Conversion to postfix. Converting an infix expression to postfix notation involves rearranging the operators so that they follow their order of evaluation. This conversion process uses a stack data structure to keep track of operators encountered in the infix expression. Single traversal for evaluation. Prefix and postfix expressions allow for straightforward evaluation with a single left-to-right traversal. Operators in these notations are already in the correct order, simplifying the evaluation process. Stack usage. During the conversion of infix to postfix, a stack is employed to manage operators and ensure they are placed in the correct order. Postfix expression storage. A string variable is used to store the equivalent postfix expression during the conversion process. Here are the three important features of postfix expressions. Operand order. Postfix expressions maintain the same order of operands as in the equivalent infix expression. Parentheses unnecessary. Postfix expressions do not require parentheses to clarify the expression's meaning or resolve ambiguity or uncertainty. Operator priority irrelevant. When evaluating a postfix expression, the priority of operators, such as multiplication or addition, is no longer a concern, as the order of operations is inherently clear in postfix notation. We consider some binary operations like exponentiation, multiplication, division, addition and subtraction and its precedence. Exponentiation has the highest precedence with value 3. Multiplication and division has the next highest precedence with value 2. Addition and subtraction has the lowest precedence with value 1. Now, let's write an algorithm for infix to postfix conversion. Pay close attention, as each step holds significant importance. Step 1. Initialize an empty stack operator stack to hold operators. Empty stack named operator stack, which holds the operators like addition, subtraction, multiplication, division, etc. Step 2. Initialize an empty string postfix expression to store the postfix expression. Empty string named postfixpression stores the postfix expression, like variables x, y, z or constants like 5, 4, 6, etc. Step 3. Scan the infix expression from left to right, one symbol at a time. For example, it scans the infix expression given, one symbol at a time, from open parenthesis on the left to the close parenthesis, the last symbol on the right. For each symbol in infix expression, if it's an operand, a number, or a variable, add it to the postfix expression. So, look at the infix expression given here. If it's an operand, that is a number or a variable, append or add it to the postfix expression. Now come to the second part. If it's an operator, do the following. There are two subdivision. Subdivision A. While operator stack is not empty and the precedence of the current operator is less than or equal to the precedence of the operator at the top of operator stack, pop the operator from operator stack and add it to the postfix expression. You can see the operator and precedence value box given below for your reference. Subdivision B. Push the current operator onto operator stack. Step 4. If the symbol is an opening parenthesis left parenthesis, push it onto operator stack. You can see the left parenthesis, which is highlighted here. Just push it onto operator stack. Step 5. If the symbol is a closing parenthesis right parenthesis, pop operators from operator stack and add them to the postfix expression until a matching opening parenthesis left parenthesis is encountered. Discard left parenthesis. Remember, postfix expressions do not require parentheses, so just discard the left parenthesis. Step 6. Continue scanning and processing symbols until you reach the end of the infix expression. Step 7. After processing all symbols in the infix expression, pop any remaining operators from operator stack and add them to the postfix expression. Step 8. The postfix expression now contains the postfix notation of the original infix expression. Now, let's see the visualization for infix to postfix conversion. Pay close attention, as each step holds significant importance. The infix expression given is open parenthesis x plus y close parenthesis, slash, open parenthesis z asterisk 8 close parenthesis. Step 1. First, the action done is that we are initializing. In the third column, you can see the operator stack. Initialize an empty stack named operator stack to hold operators. Empty stack named operator stack, which holds the operators like addition, subtraction, multiplication, division, etc. Step 2. You can see the fourth column, initialize an empty string postfix expression to store the postfix expression. Empty string named postfix expression stores the postfix expression. Step 3. Scan the infix expression from left to right, one symbol at a time. It scans the infix expression given, one symbol at a time, from open parenthesis on the left to the close parenthesis, the last symbol on the right. Step 4. Now the symbol scanned is left parenthesis. Action done is push in operator stack. You can see the operator stack contains the left parenthesis. Postfix expression column is still empty. Now, we have to continue scanning and processing symbols until you reach the end of the infix expression. So, symbol scanned is x, action done is append to postfix string postfix expression. Operator stack holds the left parenthesis. Postfix expression stores x. Symbol scanned is plus. Action done is push in operator stack. Operator stack holds the left parenthesis and plus. Postfix expression stores x. Symbol scanned is y, action done is append to postfix string postfix expression. Operator stack holds the left parenthesis and plus. Postfix expression stores x, y. Here, the next symbol scanned is close parenthesis. In step 5 of the algorithm, we have learnt that, if the symbol is a closing parenthesis right parenthesis, pop operators from operator stack and add them to the postfix expression until a matching opening parenthesis left parenthesis is encountered. Discard left parenthesis. Remember, postfix expressions do not require parentheses, so just discard the left parenthesis. Now, the operator stack remains empty. Postfix expression stores x, y plus. Now, the symbol scanned is slash. Action done is push in operator stack. Operator stack holds slash. Postfix expression stores x, y plus. Now, the symbol scanned is open parenthesis. Action done is push in operator stack. Operator stack holds slash and open parenthesis. Postfix expression stores x, y plus. Now, the symbol scanned is z, action done is append to postfix string postfix expression. Operator stack holds slash and open parenthesis. Postfix expression stores x, y plus z. Now, the symbol scanned is asterisk. Action done is push in operator stack. Operator stack holds slash, open parenthesis, asterisk. Postfix expression stores x, y plus z. Now, the symbol scanned is 8. Action done is append to postfix string postfix expression. Operator stack hold slash, open parenthesis, asterisk. Postfix expression stores x, y plus z8. Now, the symbol scanned is close parenthesis. Action done is pop operators from operator stack till open parenthesis is encountered and append the popped operators in postfix expression. Discard the left parenthesis. Now, the operator stack holds slash. The postfix expression stores x, y plus z8 asterisk. Now, we came to the end of input expression. Action done is pop all operators from operator stack and append the popped operators in postfix expression. Operator stack remains empty. Postfix expression shows the final output as x, y plus z8 asterisk slash. Let's see another example. Convert the following infix notation to postfix notation, showing stack and string contents at each step. Infix expression is a plus b minus c asterisk d. Let's look at the steps. Symbol scanned is a. Action done is append to postfix expression. Operator stack, initially stack, is empty. Postfix expression holds a. Come to the second step. Symbol scanned is plus. Action done is push plus in operator stack. Operator stack holds plus. Postfix expression has a. Third step. Symbol scanned is b, append to postfix expression. Operator stack holds plus. Postfix expression stores a, b. In the next step, symbol scanned is minus. Minus have equal precedence to plus. You can check the precedence table given on the right side of the screen for your reference. So, in the operator stack, first pop plus, then push minus. Now operator stack holds minus. Plus is popped out of the stack and hence postfix expression now stores a, b plus. In the next step, symbol scanned is c, action done is append to postfix expression. Operator stack holds minus. Postfix expression stores a, b plus c. In the next step, symbol scanned is asterisk. Asterisk have higher precedence than minus. You can check the precedence table for reference. Now, push asterisk in operator stack. So, operator stack holds minus, asterisk. Postfix expression stores a, b plus c. In the next step, symbol scanned is d, action done is append to postfix expression. Operator stack holds minus, asterisk. Now, postfix expression stores a, b plus c, d. Next we came to the end of input expression. Action done is pop all operators from operator stack and append the popped operators in postfix expression. So asterisk and minus are popped one by one out of the stack. Now operator stack is empty. The final output is a, b plus c, d asterisk minus. I hope it's clear to you. Thanks for watching. Watch the upcoming videos, Data Structures in Python, Part 4, Evaluation of Postfix Expression Using Stack. You can check the link in the description box given below. Please subscribe if you are new to my Sally and Bytes YouTube channel to stay updated with engaging content and never miss out on my latest videos. And don't forget to give this video a thumbs up.